All right, so good morning. This video is for all of you in my 127 class to get started with C++. So you've been using Python all the semester, but now we're going to start the transition to C++. And we're going to go through most of it in class, but this video is just so you'll have something to refer back to literally just get started, just to get the basics going, get it going on your machine. So to start, let's see. So one is if you are running Linux. So if we get you our laptops, which I don't think will happen until they're at Hunter, so it's just a matter of setting them up. But when you get them, they'll already have C++ installed. When you get, if you have a Mac, you probably already have C++ installed. But if you're running Windows, you may have to install C++. And let me get you some references about getting that going. And I'm also going to show you how to do this using Replit. So here, if you go to our main page here, we can go to the regular old main 127 class that all the other classes are using. And let's see, where are we? So if we come down here, you'll notice that they've got these references to these C++ tutorials. So these are good references. I'll provide other references for you later on, but these are some good references for you. The other thing that I want to show you is if you go to the 135 page. Now this is my 135 page, so it's the same as, the only difference is it's 135 instead of 127. But if we then follow this to the main 135 lecture page, there'll be this link here, Linux on Windows, which will talk about setting up Linux under Windows. And that way you can you can run, if you're running Windows 10, you can run Linux at the same time, and that should be, and then you should get that going. So you should be either running on a Mac or running on a Linux machine or Linux on Windows, and you should have C++ installed. And it should be automatically installed on a Mac. If not, you'll have to find that, and on Linux. So let me first show you how we're going to be doing this, or how this is the approved way. And this is also, I'm going to be testing all your projects next semester, all your labs on Linux. So this is ultimately how you're going to want to do it. So if you open your Linux terminal, and you somewhere will have already cloned your repo for our class, and let's say you wanted to work in a directory. So here, this is just the class code directory, and I'm going to make a directory called CPP for C++ and change into it. And what you're going to basically do is, just like you were working in Python, you're going to want to create a file with your C++ code. Now, if you're working under Linux, you can use, or Mac, you can use any editor out there. You'll just have to find an editing environment. I would not use, if you've been using Thonny, that's a Python environment, so you probably don't want that. If you're using Linux, you can probably use gedit is a nice easy one. So you can edit your program by saying hello. Gedit, I'm in the folder hello.cpp, and I can create my file. I'm not going to use gedit, but let's just say I can say hello, I can save it, I can quit out of this. There's my file. If you don't have gedit, you can always use sudo apt-get install gedit. It'll then ask for the password, which you can type in, and this will just, it's already installed, so it's not a big deal. But gedit works. If you need to find an editor for the Mac, just post something on our Zulip to the general channel, and you'll see what the previous classes have used. As you all know, I use Emacs as my editor, so that's what I'm going to use here. So I could just type Emacs and then the name of the file, but I just always have Emacs running. And so I'm just going to visit the file, and I have to navigate to the folder. And for a C++ file, we traditionally end it with .cpp. Python files we call .py, C++ files we call .cpp, and then we can start typing our file. Now, C++ is different than Python in a number of ways. One way is it is a compiled language, and we'll go over this in class. So this is just to get the mechanics down so you have the tooling right. So all the details about the language will all be covered in class. But basically, you start with a program, which is your C++ source code, and that's what I'm typing here. And like in Python, we might create hello.py, and your program might just be print hello world. I'll save that. And there's hello.py. But if I wanted to run this, I would have to run Python, and in my machine it's set to be Python 3, and then run Python 3 hello py. So I have to run it under Python because it is interpreted by the Python system. C++ is different in that you don't run C++ under the C++ program. You run what's known as a C++ compiler, and again, details will be covered in class, which basically takes your source code and translates it into a machine executable, and it does this in a number of steps. So let's go back here and let's type in a simple C++ program. So the first line that we'll usually have is this include line. And include is kind of like import in Python, but not exactly. But this is kind of saying that I'm trying to bring in my I/O stream. I want to bring in the facilities to do input and output I/O, and so I'm including that. And then you must have a main program. In Python, you can just start typing code like this. Let's just go like that. In C++, you have to write a function, and the function, there has to be a function named main. And so this will be what is run when you run your Python, when you run your C++ program. Now in Python, we could have defined main like this. So let's look at some differences here. First off, in C, we've got main in parens, and here we've got main in parens, but notice there's no colon. Instead, and in Python, we basically use indentation. But in C++, we're using these brackets to denote this is the content of my main function. I also have to explicitly return something, and I also have to say here that this function, what type it returns, and it has to be int. So we'll cover this more in class, but for now, let's just say this is boilerplate. You just need this. And then you have your code. And instead of print, C++ uses standard cout, and another difference is we have to have a semicolon at the end. All right, now let me just change my Python program just to make it the hello world again, and whoops, and no main. So we'll already see, if we come back to our folder, that, and the tildes is just the automatic backups, hello.py is a one-liner, but hello.cpp is a little bit longer. But the idea is the same. When you run your C++ program, what it does is it will immediately start main. Python just goes top to bottom, but C++ will find main and it will execute main. It will run that main function, which can then call other functions, etc., etc. So how do we set this up to work? Well, we can't just run it. We have to first compile it. So the way we do that is we run the G++ program on hello. And we'll notice here that it created something called a.out. And to run it, we can say /, dot means for in this directory, / to separate it, and run a.out. Now notice that that looks a little bit different than the Python version because it doesn't have that new line. If I want the new line, so that's another little difference, I have to explicitly say that. So I can say that by just going, at the end of this, I want to print out a standard end of line. So I can compile my program again. And now it's the same. Now, let me remove a.out. Usually I'll just compile a program and it'll make a.out. But if I wanted to make another name, if I want my executable to be called hello, I can say g++-o and then whatever the name is, hello, and hello.cpp. So now that creates hello, and so that's how I can create this under another name. Now, let's say we have an error in this. Like, if we compile this, it gives us an error. And we'll read the error, and they can be a little intimidating, but it says expected initializer before std. So I'm really just focusing on that first error. And so it says something before that, and I look here, it's like, oh yeah. And notice that if your editor set it up, it gives you like these little markings here, like it gives me this one over here, which is basically telling me there's something wrong there. And it says expected function body after the function declarator, which basically means I need that. Or maybe I have a misspelling like that. And it gives me a different error. That's not declared. Did you mean standard : cout? Yes. So basically, I just have to keep doing this G++ line until I get no errors and everything works, and then I can run my program. So that's basically that. Now, in Python, you also can have variables, as you can in C++. Like in Python, you can say A equals 20, B equals 30, C equals A plus B, and then print C. And so if I run this in Python, we get our 50. Now you can do the same thing, of course, in C++, but of course it's a little different. In C++, we can't just use variables. So for example, if I say A equals 20, and I need a semicolon at the end of the lines, and if I try to compile this, notice it says A was not declared. In C++, before you use a variable, you have to declare it. So if I want a variable A, I have to say I'm going to have a variable A, and I have to say what type of information it's going to be. So I can say here, I have A and I want it to be an integer. Or I can say give me an A and give me a B. And now, of course, I can compile these, and it runs. I can also compile it with this -w all, which stands for warnings all. It gives me extra warnings. It's a kind of a good way to protect yourself from programs, little pitfalls in programming. And it says, hey, you made A, but you didn't use it. You made B, but you didn't use it. And that's because I want to use these, so I'm going to want to create a C, and I can do multiple lines like this. So I can say C equals A plus B. And if I want to put multiple things together, I just chain them. And another way to do a new line is with the /n. So it's going to here print A, which is just the variable value A. It's kind of like in Python, it'll interpret that. Then it'll be the string with the plus, then the B, then the equals, etc. So let's save that. Let's compile this. No warnings, no errors. And 20 plus 30 is 50. And that's pretty much it. So I'm just going to git add hello.py, just so it's up there, and hello.cpp. And we'll say git commit and push this so it's up in class code. And great, that's everything, and that's it. And so this is basically, and I'm going to show you one more thing after this, but this is kind of the approved way of working in this class on Linux. you use your editor, you create your file, you compile your program. Now, and of course, once you get all your laptops, it'll all be set up for that. And when I test your programs, you know, in 135 for the labs, I will be doing it using Linux. So if you're using some other system, if you're using Windows or using Mac, you want to test it on Linux to make sure 100% it does what it should do. Now, some of you, once we get the laptops, you'll 100% be doing this. But let's say you're running an older version of Windows and you can't use the Linux subsystem, or you cannot get things working on Mac quite right. So just for the time being, you can also use, some of you are using Replit, and you can continue to use Replit. And so here I'm logged into Replit. And so if you already are set up with Replit, if you're not set up with Replit, then just don't use it. That's fine. But if you are set up with Replit, you have probably some REPL for your 127 class. Like I have this one over here, which I guess I set up at some point when showing you this. And the way you can use this is very simple. So one is you can use it kind of similarly. Let's make a new folder, and let's call this C++. And then let's, under this folder, let's add a new file called hello.cpp. And that's a C++ file, and we'll just type in our program. I'll just put the /n into there, and the semicolon, and there's my program. Now, to run this, we have to use the shell. So we open up the shell window, and I'm just going to make this whole thing bigger so we get a little bit more real estate here. And so we can see here that we've got my CPP directory. I can cd into it. So this is just like the terminal. And I am going to g++ hello.cpp, and notice it created a.out, and I can run it. So it's the same thing as using the Linux terminal, but I'm doing this up on Replit. And of course, if I have an error, like maybe that, it gives me the error. I have to read it. I can't figure this out. What's going on? And then I can fix it like that. And so come over here. Now, of course, if you're using Replit, you already know how to sync this with GitHub, and so you'll be able to do your work, etc. All right, so all you really have to do for our next session is just get this all running, and I'll put this up in Zulip with the specifics, and just write a little C++ program that compiles and runs, literally does the stuff that we just did in that previous example. Two variables, adds them together, prints out the result, it compiles, it runs. Put an error in your code. If you don't get an error, to see an error message. If you do, fix it. If you don't, put an error in so you can read the error message, then fix it. And that'll be that. And then in class, we'll cover all of the stuff in much, much, much more detail. What a compiler is, C++'s history, and all of that. And but this way, you'll all come in having a working C++ system. All right? So that is it. And yeah, so bye-bye.